In this video, we are going to go over melting and boiling points. Melting and boiling points are measured at normal atmospheric pressure or sea level. The boiling point is the temperature at which a substance undergoes a phase change from liquid to gas, and the melting point is the temperature at which a substance undergoes phase change from solid to liquid. For water, the boiling point is 100 degrees Celsius, and the melting point is 0 degrees Celsius. A heating curve shows how the temperature of a substance changes as heat energy is added. So horizontal plateaus represent changes of state, and the temperature is constant, and heat is absorbed for phase change instead of increasing the temperature. So this shows that temperature is increasing. Temperature is on the y-axis, time is on the x-axis. Over time, you have your solid, this is solid, and the solid is warming. You have a plateau. We have solid and liquid together because the solid is melting into liquid. At this point, all of it is melted into liquid. The liquid is warming up, and then you're at a plateau at a temperature, which is the boiling point, where you have liquid turning into gas. So you're liquid and gas, and then you have all gas, and your gas is warming up. A cooling curve is similar to heating curve, but begins with the gas phase and shows the decrease in temperature as a substance is cooled by removing heat. We usually show heating curves though, not cooling curves, but there is a cooling curve. This is the heating curve for water. You can see as heat is added to ice, the temperature, so ice, solid for the ice, the temperature increases linearly until you get to the melting point of water, which is 0 degrees Celsius. The temperature remains constant at 0 degrees Celsius as heat, even as heat continues to be added. Instead of the temperature increasing, a phase change occurs, known as melting. At the melting point, the heat added goes into breaking the hydrogen bonds between water molecules, and this first plateau corresponds to the melting point of water at 0 degrees Celsius. Once all the ice has melted to water, then a linear increase in the temperature of water is again observed right here. So now you're heating up the liquid water until you reach the boiling point of water, which is at that 100 degrees Celsius mark. A second temperature plateau is shown when vaporization occurs, and this is at that boiling point. And then once all the intermolecular forces are broken, then you only have gas molecules, and the gas molecules are being warmed. These are melting points and boiling points for different compounds. You can see oxygen has a melting point of negative 219 degrees Celsius and a boiling point of negative 183. And you can go all the way down to phenol, which has a melting point of 41 degrees Celsius and a boiling point of 102 degrees Celsius. Melting points and boiling points are unique physical properties of a substance. So every substance has its own unique melting point and boiling point. The boiling point is the temperature at which a substance changes from liquid to gas. The melting point is the temperature at which a substance changes from solid to liquid. A heating curve shows how the addition of heat affects the temperature of a substance, starting in the solid phase and through to the gas phase. At the melting and boiling points, heat continues to be added, but temperature remains constant because a change of state is occurring. Instead, that energy being supplied by the heat is going into breaking bonds instead of just heating up the molecules.